Now we will establish the hydrostatic equilibrium condition. So here I have taken a small element of the fluid which is static, which is not moving. So here you have the base, and as you go in this direction the height will be increasing. So now I am going to take a particular element whose thickness is delta z, and the cross section area of this is given by capital S. Okay, and I have taken two limits, ZB is the base, ZA is the final one. Okay, in between I am going to establish the hydrostatic equilibrium condition. So what are the forces which are exerted? So if you take this element outside, then there will be a pressure will be acting in the upward direction, and P plus, this is dP, P plus dP will be acting from top in this particular direction, and then you will have, of course, you have the gravitational force Fg. So applying the same equation, the forces exerted on the vertical direction, y axis, and equating it to 0. So let me take the first one, this as the positive one, I will take it. So I will take P, and what is the area, sir? Area is equal to S minus, this is acting in the top to bottom direction, this is P plus dP, and area is also again the same, area S, minus Fg is also downward direction, Fg is equal to 0. Okay, now we will crack Fg value. This I will call it as equation number 1. Fg we know mg by gc, and you know mass is equal to, you know, density is equal to mass per unit volume. Therefore density into volume is equal to mass, and here in our example volume is equal to, volume of this element is equal to cross section area into the height element, that dz. So if we substitute all these values in this, instead of m I will replace it as density, volume, and g by gc. This will become density, volume is equal to S into dz, g by gc. So this value I am going to substitute in Fg. So this will become, okay, will become P into S minus P plus dP S minus Fg rho S dz g by gc is equal to 0. So now if I expand this, this will become Ps minus Ps minus S into dP minus rho into S into dz g by gc is equal to 0. So you know these two terms will get cancelled, and here we have S, here we have S, this will also get cancelled. So you will have only minus dP minus rho dz g by gc is equal to 0. So this will become dP is equal to, I will take this side minus, I will take this side, minus dP is equal to rho into g by gc into dz. Okay. So now I will try to integrate this equation. So if I try to integrate this equation, what I am going to get is, yes, minus dP integration is equal to integration of rho g by gc dz. Now at the bottom, when z is equal to zb, p is equal to pb. At the top, when z is equal to za, p is equal to pa. The same thing I am going to write. So at the bottom I will write as pb, at the top I will write as pa, at the bottom I will write as zb, at the top I will write as za. So this will become, okay, so after integration, doing applying limits, pb minus pa is equal to, this is constant, rho g by gc, this will become za minus zb. So see, pb minus pa is equal to rho into g by gc bracket start za minus zb. So this is the hydrostatic equilibrium proof.